Hey everybody, welcome. I'm seeing that quite a number of people are getting in and some familiar names also. Welcome to you all. Was quite a large number of people subscribing to today, so apparently this is somehow hitting the bullseye. I think, and that's what I wrote on Twitter, it's a topic, a subject that needs to get more attention in our world. And as Kamil wrote, Kamil, our speaker of today, that we're mostly doing a lot of things around building apps intuitively. And is there maybe something helping us? And that's Solid that could help us. And as Kamil, we were discussing a couple of things this before the session started. It will be looking from a high overview on app development and how Solid can play a role in this, while guys like Vieco is doing that more at the level of the code. So solid principles for app architecture in Business Central. Welcome everybody. Good morning, good evening, good afternoon. I'm your moderator, Luc van Vugt, and today will be, what is it, our 83rd session. And Kamil Sacek is our speaker for today. Welcome, Kamil. But before I'm going to hand over to Kamil, always a couple of practical things. If you want to interact with questions, and please do be welcome to do so, use the GoToWebinar question window. For those not familiar to it, it should be somewhere on your control panel. I, as the moderator, will pick them up, and as agreed with Kamil, we will pick them up later unless the context is so relevant to pose the question. If we would put it later, then all of a sudden it might not make that sense anymore. So use the question window and I will pose it to Kamil at some point during this session. As always, I'm going to try to get this recording, as it's recorded, as you might know, on YouTube. Might not succeed today, but otherwise tomorrow morning, and it will add to still growing collection of more than 80 recordings at the moment. If you want to stay in the know, and most of you probably do, we sent out a newsletter last week with the latest schedule we have. This is the URL to get yourself subscribe to it. You can find the listing on our website. Kamil's one is of course still on it, but as always, I've got this listing here with all the sessions ahead. Almost every second week there's one planned. There is one interval in between, and that's because I think of Eastern. No, there's an interval. No, there's an interval somewhere else. But nevertheless, there's not much left this season before on the Northern Hemisphere summertime. But in June, end of May, there are still a number of slots. So I'm still looking for speakers. Be welcome to be one or suggest a topic. Use it as a kind of stepping stone to be a speaker, to become a speaker if you dare to do that. You're more than welcome. Before I'm going to hand over to you, Kamil, and yes, I didn't say so, but I'm very pleased you stepped into my invitation to do this presentation. I was in your session last year when you did this on Days of Knowledge, and I think it's really worthwhile that it's going to be shared with more of us. So thanks to our sponsor for NAV, we're able to do this. And yes, that's more or less the key, the signal to make you presenter. So here we go, going to make you presenter, Kamil, and feel free to share your screen. Yes, it's in view.
Hello, everyone. You should see my screen now.
I do.
That's good. And I want to introduce you to the solid principles if you don't know them, or I will look at them from the high-level view as Luc already mentioned. My name is Kamil Sacek. I'm product development manager in Navertica in Czech Republic, and I'm MVP for last 19 years already. What is ahead of us? We will need to talk first about what is architecture at all, because if we will talk about solid, we will talk about principles which are used in architecture, in software architecture, but we need to understand what is architecture at all. And then we will go through the solid. Now there are just abbreviations, but we will give them some meaning later. What is better? One question, two possible answers. Software which is perfectly works but is impossible to change, or software which doesn't work but is easy to change. Of course, now I'm speaking from the developer side of that. Yeah, how I as a developer see the software, and of course, customer view could be different. A customer will like, of course, the perfectly working software and will not care much about possibility to change it. But I think even that already changed, and it was changed by the COVID time, because many customers find out that they need to be very flexible with their software when they want to be flexible on the market. Then the software which perfectly works and impossible to change, you maybe know already this kind of softwares, because if you imagine some old NAV installation on some customer side, that's exactly this software. Yeah, it works. It have all the features and so on, but nobody wants to upgrade it. Nobody wants to touch it. Nobody wants to change anything, because if they do that, something will stop to work. And of course, from that point of view, the software which doesn't work but is easy to change is much better for us, because if it doesn't work and it is easy to change, we can easily change it and it start to work. And that's the main reason why we need to think about the architecture, how we can change the existing software easily and keep that during next years. Definition of architecture. From Grandy Butch, architecture represents the significant design decisions that shape a system, where significant is measured by cost of change. It means architecture is set of design decisions, how you decide during the architecture to make that architecture good, and this good is measured by cost of change. It means if the cost of change will not change by our change in the system, that's a good decision. If the decision leads to the system which is or the cost of the change will rise during that, because that decision, that's the wrong decision, and we need to take it into account. Yeah, it means make everything to keep the cost of change constant and not rise it during the development. Of course, to work correctly with the architecture, it's good to have some rules, some principles which describe these decisions we need to make during the process. And one part of these principles are the solid principles, are the rules and principles you can find or you can make yourself for your solution or for your case, because every company, every partner is different, and maybe you have different requirements for the architecture. But good is to write these rules and principles, because you need to share them with people, with the architects. And of course, again, even when you have all the rules and principles written, if you take two people and they will be both architects and you give them same task, the result could be different even when all the same rules and principles are applied, because architecture is more like art, not some physics or some exact things. Yeah. Architecture is important and features are urgent. It means, yes, customer and managers and so on, they are focusing to the functionality because it's urgent, because that's what customer is paying for. But we know that architecture is important, because without correct architecture, the functionality will be a problematic, or create the functionality, change the functionality will be problematic. It means architecture is important. Of course, we are talking in context of Eisenhower metrics, if you know that from different courses about time management and so on. That's what we are talking about. Important things which are on the top line and urgent are in the left side of the matrix. Yeah, it means focus on the architecture because it's important. Features are urgent, but not so important things, and we need to think in that way about these things. The architecture is responsibility of whole team, not only of the architect, because if only architect is responsible for the architecture, then he will decide something, but developers will do it in different way. We know the developers. I'm developer too, and I know that if I will not think about the architecture, I will do things which will not be good in that picture of architecture and cost of maintenance or cost of change of the solution itself. Now we are going for the solid principles. Solid principles were named or collected together with by Robert C. Martin, and of course the principles are from different people and different areas, but he described them and collected them together in the book Clean Architecture, which is based for that session I have. We have single responsibility principle, open-close principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. And now we will go through these principles, and I will try to explain them on everyday things or things from outside the software engineering, the development, and I will try to apply them to Business Central application development. First principle, single responsibility principle. You already know and you feel that it's good that there is only one responsible person for some process or for something. This is exactly that thing. If something is responsible only to one reason to change, or user, stakeholder, or actor, that's good. If we have a multiple users responsible for one thing, we have a problem. The example here, we have a fork, we have a spoon. Of course, we can create something which is named spork, which have both functionality together. It is legal to have something like that. It is okay to have something like that. But the architecture of the fork and spoon is much simpler from cost of change measure than the spork. Yeah, because if we want to change the spork, the cost will be much higher when, for example, we want to change the part which is a fork functionality on that object. That's the reason why it's better to keep the things as simple as possible, because the cost of change will be much lower than when compared with something which is more complex. What is module in this case? When we are talking about that module should be responsible only to one actor or user. It's defined as a unit of deployment in the book. It means it have own version, you can deploy it separately. In our context of Business Central, it is extension, the application, one extension which we can deploy to some environment. Of course, we can even not talk about just about application. We can apply that to any part of the code, not only module, but we can talk about, for example, function. Function should be responsible to only one functionality, to one actor, and so on. And standard example of breaking the single responsibility principle. What came first to my mind was reservation table. And I think you will say yes, exactly. That's breaking of the single responsibility principle. It can look like that today. I had a discussion on that subject with one person who participated on the original architecture of that table, and he told me that it was really good architecture in the time when they were creating that reservation table. And I understand, and it's true. From today's point of view, it looks like we can make better architecture for the reservation table because we have better tools how to do things now and how to solve that things now. It means take it with some just reservation table looks like, but maybe not. Monolithic application, that's definitely if you take everything, all the changes, and put them to one application, that application is responsible for everything and is responsible to all the users and so on. That's wrong. We have a problem. If because if someone wants to change something, we can break something else easily and so on, because everything is together and tightly coupled and interconnected and so on. Another example, if you take one report which was created for financial department but can be used even by sales department, for example. In this case, you have a problem if someone from sales came and, okay, can you add some fields here to that report because we need to see that value here. And you say, okay, I will put that field here. You change the report, and then someone from financial department comes and say, hey, why is that field here? We don't need it. We need another one. There is no space anymore on the paper. Please, can you remove that and put that value here? And say you can say yes, okay, I will change that. And we have never-ending loop of changes because two persons are trying to give us the reason to change, and that's the reason or that's the effect of breaking that single responsibility principle. What can help to keep that principle in your architecture? Ask what is the responsibility of the app, object, or function of the or the component. Ask that question if you are thinking about something. Because if you don't know what is the responsibility, then it's a problem. Maybe problem of the naming of the object or application, because maybe you are trying to have application responsible for multiple things, and it's hard to name such an application, or you don't know exactly what it should do. Add actor or user or stakeholder to the user story. If you are using Azure DevOps and work items and user stories, you can easily add the actor field to that user story and keep that value here directly, because then you can easily detect these conflicts when one user story change some functionality from another user story, and there are different actors or different stakeholders. You know that there could be a conflict, and you need to discuss these changes with both actors or stakeholders and so on, and make only one responsible for this user story. And don't create multi-purpose objects, tables, and so on, just to save some money. Because maybe you will save some money. That was common when you needed to license, for example, the tables in your license in on-prem. Now in online, we don't need to think about the IDs and so on. It's better to keep the architecture clean from that point of view. Second principle, open-close principle. Open-close principle is defined by the sentence, software artifacts should be open for extension, but closed for modification. It means we can extend the functionality, but we should not modify existing functionality. Changing by adding, not changing the existing. That's the basic feature of the platform, because we can extend the base app from Microsoft, but we can't change it directly. Of course, if you connect to the GitHub and you can connect there and implement some changes and so on, of course, that's okay. It's not breaking that principle. But from architecture point of view, we have something, we want to change it, we can extend it by another application and do what we need. Yeah, that's the basic functionality. Use it correctly, think about that. And of course, part of that principle is using the interfaces and eventing to connect these things, because interfaces and eventing are allowing us to extend existing functionality without the need to change them. Of course, if there is no event for what we need, someone needs to change the core app or the app we are building on top of and give us the event to somehow extend this functionality. Separate functionality based on how, why, and when it changed, and organize that separated functionality into hierarchy of components. And again, it's in line with architecture we as Navartica are doing. We are not developing for the customers or the products in one big extension, but we are creating multiple extensions based on some rules and interconnect them as a dependencies or through other apps which are connecting them together. And part of that open-close principle are even some rules about the dependencies and how they should be set in your solution. Because there is a rule that high-level policies, central concerns, or business rules should not depend on peripheral concern or specific implementation or low-level access code, access apps. And it should be in opposite. It means the low-level application should depend on the high level. If you think about business, not business, but base app from Microsoft as a high-level functionality, because it's core of the business central functionality. It's the business rules which are there defined and implemented. Then our apps don't create such a high level rules. We are defining some lower level things around that, and that's why we are depending on the base app, not vice versa, not base app depending on us. And we will talk more about that. Example, mixer and the attachments. Of course, the attachments needs to know to which mixer they will be connected, but mixer don't need to think about the attachments, because the mixer itself doesn't care about the attachments attached to it. Yeah, because who cares? You don't need to change the mixer if you want to put another attachments there. And now that's description of how we can implement that open-close principle in Business Central. Don't change the existing code if the kind of the change is different than the original code. It means don't put new things to existing code if they are not in line with the original responsibility of that code, because you will have a more complex solution to maintain, and it will be harder to extend later in time, and rather put that change as an extension or something on top of the original code. Check if dependency is in correct direction, and that's, I think, one critical rule, because it will prevent you to create circles in the dependencies. And every time it should be specific to generic or abstract app, low-level rules to high-level rules, not important, too important, not stable app, too stable app. If we are thinking about the stability, of course, a stable app is the one which is not changed too often. Unstable app is what you are changing every day, for example. For me, the stable app is base app. Unstable app is app with some report, because the report is changed every week because someone wants new fields or wider columns or something. Yeah, that's unstable app, and it means the unstable app must be depending on the stable app, not in opposite. And for that, we have something defined in our company, which we named the SALI architecture. I had some session already about the SALI, and you can read about the SALI architecture on my blog if you are interested more in that part. Again, just illustration of the dependencies. Critical, abstract, stable apps, high-level functionality is core things, and everything else should be depending on that. If you are talking about multiple apps and you don't know how to connect the dependencies correctly, think about these attributes of the apps, stability, if it is critical or less critical, specific or abstract, and so on. This will help you to decide correctly how correctly do the architecture decision in that part. Liskov substitution principle, introduced by Barbara Liskov already in '88. It's a really old principle, which talks about that you can replace one part with something else without need to change the depending part, without change of behavior. It means it helps us to replace some parts of the system with something new without need to change it. You can see that's, for example, pricing module. If we have correct architecture, it's not problem to change the pricing module in the solution, and we don't need to change anything around. If we have a architecture which was done in NAV, it's hard to change the price module or replace the price module with something else, because we will need to change everything connected to that module. Yeah, and that's why Microsoft is trying to refactor. That's all the apps refactor all the code existing to something which will be much more modular and will be using the Liskov substitution principle to be able to replace the parts. Maybe you already know the first refactoring which touched the number series module in Business Central. One example when you break that principle, you can see code like that in your solution. Yeah, if you have case and based on some type you are calling different functionality, this code is breaking the Liskov substitution principle, and you can't easily extend such an extension, such a code by, for example, new type. Yeah, that's a standard example. If you want to implement new sales line type, it will be very hard in many codes existing in posting and everywhere, because if it is not prepared for that, you can change that code and extend with your new type. If you use interface, it's easy, because in code you have only one line, type.post, which call the posting routine for the line, and the implementation for different types will decide what will be done in that functionality. That's application of Liskov substitution principle in AL. Yeah. It means if you tend to put new if then else or case to your code, think about it and consider using interface to not break Liskov substitution principle. Another things which can help you if you are thinking about implementation of some functionality, think in a way that you say that the process will work with some unknown thing or something. If I will do the architecture, for example, for sales line, and I will think about unknown thing, I'm selling something or something unknown, and I will create the process in that way, it will be much easier to extend because everything will need to be prepared for something. And the something could be GL, resource, car, house, or anything later as we need. Yeah? It means if you are thinking about something, put that wording into your definition. Something will be sold, something will be processed, something or something unknown, it's on you, but it will help you to make that process more generic and extensible. Interface segregation principle. This principle is about, or the definition is, clients should not be forced to depend upon interfaces that they don't use. Example are these mobile phone chargers or laptop chargers, which are separate because they have different interface, different ending, and instead of the universal charger, which have both endings. Of course, you know these universal chargers. It's okay to have them, but again, from the architecture point of view, they are more complex, and the cost of change of such a solution will be much higher than cost of change of these separate things. Because if you want to add new charger, it's not a problem to create new separate charger here. But if you want to modify that solution, you need somehow change this part in the middle, attach some new ending, and solve different things, like, for example, to not have some electricity on this end when some other end is used, and so on. Yeah, it means it will be much more complex than when you have separate solution for the separate problems. We don't want to pollute application or interface with not needed dependencies or functionality. And I will demonstrate that on the apps. If applications are loosely coupled, don't make them dependent on each other, because if they are loosely coupled, it means they can exist without each other, and you make them depending, you are killing that things that, because you will need to have them both even when you need only one of them. Use dependency only if the functionality is really tightly coupled. It means it has no meaning if the app A have no meaning without app B, for example. Example here, I have my application. In this version, it is depending on Czech localization and on some app source application. For example, I'm extending some warehouse system from app source and connecting it with some local functionality, which is only in Czech version. I can do that thing, which is much better, because my app is now not depending on Czech localization, because I extracted that part of my app to separate application, which is depending on Czech localization and is depending on my application. Why? Because my app for Czech localization is more specific. It's working only for Czech localization, but my app will now work with W1. It means with all the localization which exists. Yeah, and that's why my app Czech is depending on my app, because it's low level functionality, more specific than the app itself. It means if I'm adding some feature to some application which requires new dependency on some new app, it's maybe better to keep that part outside that application and make it only depending on my original app, because I don't want to pollute my app with dependency on something which is not really needed for most of the functionality in my app. Yeah, it means interface segregation is about not polluting things with some dependencies which are not necessary. And the same for interfaces. If you are defining interface and you want to add new method to that interface, think about it. If you really need that method for all the interface implementations, or only for few of them. If only for few of them, maybe it's better to create new interface and put that method there and use it separately than not pollute the original interface with that functionality. And many implementation will say, okay, I have this method, but it's doing nothing because I don't need it. That's the pollution, and we don't want to have that. That's the interface segregation principle. And last principle is dependency inversion principle. And for me, I see dependency inversion principle more like a tool which is helping us to implement all the other principles we were talking about today. Yeah, dependency inversion is about the thing that when you call one function from one app, some functionality from another app, it's common that if you call from A to B, A is depending on B. It means in my app, I'm calling the function from base app, then I'm depending on the base app, and that's all. I can call that functionality. But dependency inversion is changing that dependency direction of my app. Yeah? And that's why we have the events and why we have interfaces, because those are the tools we can use for changing that direction of the dependency. That's why base app can call our app, but we are still depending on the base app. Yeah, that's the dependency inversion. Base app know nothing about our app, but can call our functionality through the event or through the interface. Yeah. That's the dependency inversion principle. It's part of the dependency injection features of different languages, and it's tool for keeping the correct flow or correct dependency directions between your apps, and not only between your apps, but between your code itself. Yeah. And example, power socket. You have a plug, you have power socket, you have copper wires and aluminum wires. But the power socket is abstraction only, because power socket know nothing about which wires are used behind that power socket, and the power socket know nothing about your plug, what you will connect to that power socket. It means if I demonstrate it as a dependencies, the socket is abstract app, and all other things are specific apps. That's why they are depending on the socket. Yeah, and socket know nothing about the wires, socket know nothing about the plug, but plug know about the socket, because he needs to have the correct shape to fit into that socket, and wires are connected behind the power socket, and doesn't matter which one they are, because my plug doesn't care about that, socket doesn't care about that wires, and that's the reason why the dependency inversion principle was applied to that. And another look at that. Again, we are going back to the open-close principle when we were talking about the correct dependency direction, specific to generic, low-level to high-level, unstable to stable, not critical to critical. And if we find out that we are trying to add dependency in opposite, we can use the dependency inversion principle to switch that direction. Yeah, it means my app is depending on base application, but base application is calling functionality in my app through event or interface. That's a result of the dependency inversion here. And we are approaching end of the presentation, and I want to show you some practical application of these principles when I am refactoring some monolithic application. I have my base application of my solution. Yeah, that's base app because everything is now inside that app. It has now dependency on app source application because we are extending something from app source, and I have localization dependency because some part of my solution needs some check specific things like advanced invoices or advanced payments and so on. And now I will try to implement different principles and show you the effect. Interface segregation. We don't pollute the base app with dependency on check localization because it's there only for some small part of the application. Of course, this is not the correct thing or correct result because base app is defining business rules, is generic app, but the base check app will be peripheral concern. It's just something which is not business rule, it's just additional things for my application. It means we need to switch the dependencies. It means we implement the dependency inversion principle and open-close principle to keep the correct direction of the dependencies, and it should look like that. After implementing these principles, my base app is not depending on check localization anymore. It's not depending on app source app because I have some connector up here connecting the base app to the app source, and some base check app which is connecting the functionality to check localization. Another step, we are implementing single responsibility principle. It means base app is responsible only for the business rules and the core functionality, and we are extracting reporting. It means all the reports and APIs. We extracted the APIs to separate app. And again, because API and reporting are just peripheral concern, they are depending on my base app. That's correct dependency direction. And of course, because we want to have a simple way how to replace the app source app for another app source app, for example, to be compatible with the Liskov substitution principle and interface segregation, we just created some abstract app which define maybe some interface without any implementation. We are calling the functionality of that interface from our base app, and we don't care which app source app will be connected through some connector to that solution. It means if we decide later to use another app source app, for example, for some warehousing, we can create new connector app for that solution, implementing the abstract interface here, and we can switch to another solution easily if the interface is correctly designed for that purpose. That's the Liskov substitution principle and interface segregation principle in reality, used for keeping the architecture clean and easy to change with nearly constant cost of change of the solution. Everything is correctly ordered. The dependencies are going in correct direction. Of course, everything is depending on the base application from Microsoft because that's the highest level app we have. And one thing for thinking, or you can think about, is that correct or wrong? Yeah, we have a base app from Microsoft which depends on the system app from Microsoft. If we think about that in context of solid principle, we will say, okay, base app are business rules, but system app are just peripheral concerns. It should be maybe in opposite in that case. Yeah. But it means it should be like that maybe. System app is depending on some system interface app which is abstract, and base app is depending on that abstract app. That will be correct architecture for me. But true is that it is already in that way defined, because if you look into the system app, there is interface and there are implementation separated in different objects. It's not separate app, but it's separated on object level and code level, and it's okay, and it's in line with the solid principles in this case. Because in your apps you are just depending on the public interface, which is defined in the system app, but the implementation of these are somehow isolated from that part and are separated in internal code units of that application. Don't be soft, be solid. That's on end of this presentation itself. And now we have a time for questions, if there are some.
I was going to say, actually, there is no question, but just one
pop-up
from John Long. To play off your example where the warehouse user requests fields ABC and finance request fields XYZ, you end up with an extension or two, but both users see all 6 fields. This seems like a spork. How do you handle this? So it's a fork for warehouse and a spoon for finance.
Yeah, I think that's a good example of the problem itself. Of course, you can have it like that, but you need to choose which part of the company will be responsible for that report. It means you need to choose, okay, owner of that report is finance, and they will communicate with the warehouse part of the company what will be on that report, or it's warehouse and they will communicate with finance what will be on that report, but only one could be responsible for that report. And that person will be responsible for the communication around the changes they want regarding that report. Yeah, it means it could be like that. It could be one report with everything for both departments, but only one department must be explicitly set as an owner. And the problem is how you will describe that responsibility for your consultants to know that. Yeah, to not accept, for example, requirements for change from warehouse when finance is responsible for that report. It means it must be somehow described, somewhere stored, that finance is responsible for that object and not warehouse. And if warehouse wants the change, they need to communicate with the finance, and finance needs to say, okay, it will be like that or not. Yeah, I think that's the solution for that.
Okay. I asked John if it's validly answered for you, John. If not, continue with your parts. No other question. I was very happy personally about the dependency inversion to see it again. It is still some challenging one, some itching one, because we're used to just build up. You got base app and you put something on base app and you put something on that app, and doing that inversion is well, like turning your clothes inside out and have to look at it differently. But I'm very pleased with this one.
Yep. Yeah, that's we really have right now more than 1,000 apps or extensions for our customers together with our products. Yeah, it means we generated really big count of extensions already for the customers, and I think it's really bring us simplicity when we need to change some process, because it's easy to take the small app and change it and extend it with some new functionality, or create new small app to do that. And we don't need to go into one big app with everything. It's much faster and it's working. But of course, it's dangerous because if you don't have all the things around to manage such a count of apps, and so on, you can be overwhelmed by other things around to maintain these apps and so on. But of course, it has some pros and some cons. But everyone needs to think about what it brings you, what it takes from you, and so on. And the solid is big part of the architecture we need to think about when we are creating the changes.
And that's part of your solid architecture that you have,
yes,
if I recall it right, sitting in your
yes,
session last year on that topic, that your pipeline always creates this graph of how things are relating to each other to keep overview on the structure.
Yes.
Because that's then the specific challenge that you need to have to know where everything is and how they relate to each other.
Yeah. And, for example, it's even when we have all things like that in place, we had issues like some subcontractor created app which was depending on our extension for that customer, but we were already depending on their app. It means we have a cycle. And now pipeline started to fail just because because they were not able to correctly do the ordering of publishing the apps into the environment. And it was just because they created dependency in wrong direction, because their app was generic app. And now they tried to act as a specific app, and it breaks everything. It means, the direction of the dependency is critical, and the dependency inversion principle is one the most used. But of course, the all other principles are important too.
Yeah, and like I think I mentioned it in the short introduction, and as we discussed it, so this is clearly you're applying solid at, let's say, app level, extension level. That's at least the story here. So how do you organize your apps, and how do you have dependencies one way or the other, inversion or not? And like Viego is more at the code level. You could say inside your app, you could apply the same rules. How do you build up your code in one app and make things, replaceable?
Yes, exactly. It's because the single responsibility, for example, on the code level, if I have function which have some name, everything what is inside should be in line with that name of the function, and mostly the function should do only one thing, not multiple things. Because if it is doing multiple things, then we have the code which was in code unit 80 or 90 in the code or on run function, which was really long. And that's because it was trying to do too much things together.
Well, maybe it's not the best example because code unit 18 has been restructured, but it's still having
of course,
multiple responsibilities.
The version in NAV.
Yeah. Okay. Let me open up, or let's show this screen to thank everybody for being here, and especially you, Kamil. Very pleased, as I said, that you stepped in and surely triggered me or refreshed things that I have been looking at on Solid, and learned a lot today again. Thank you very much. I think we're closing up, so nicely on time. Hope to see everybody in 2 weeks' time when there will be David Veldhoff stepping in. Originally, it was Arend-Jan Kaufman planned to be on that session, but due to private reasons, that's not going to work. But David came up with a topic, actually continuing on the presentation that Andrzej Rizowski did 2 sessions ago, I think, on code analysis, and actually showing how you could do that with VS Code extension. So hope to see you in 2 weeks' time. Wishing everybody a good remaining part of the day or night or whatever. And Kamil, thank you again.
You're welcome, and thank you for organizing that.
More than welcome.